Hey everyone, today we're going to be going over heap sort. Heap sort has the time complexity of O of n log of n, so it's one of the relatively better sorts. So I'll link a video below where you can see the explanation for what heap sort is, but for now we're just going to go over the code. So let's write the first function. So the first function that we want to write for heap sort is actually heapify, because heap sort utilizes heapify. So let's write the function for heapify. We want heapify to create a max heap from an unsorted array, given the array, the length of the array that's unsorted, and the parent index of the node we want to sort from. So that would be the array, the length of the array that's unsorted, and the parent index of the node we want to sort from. We're going to create a variable for the largest node so that we can compare the parent node to its left and right nodes. So let's set the largest to the parent index first. So let's say our array is, let's just say for example, it's 0, 1, 2, 3, 4, 5. Just for simplicity's sake, I'm making all of the values equal their index. So the left node of 0 is 1, and the right node of, so the left node of 1 is 3. So the left node is just the parent index times 2 plus 1. So let's make a variable for left node. And the right node, as you can see here below, would just be the left node plus 1. If the left node is larger than the parent node, then we want to reassign the largest to be the left. And if the right node is larger than the largest, then we want to reassign the largest to be the right. So let's write some if conditions. And of course, we only want these conditions to run if they're within the unsorted part of the array, and that's represented by the length that will be passed in. So we have to, these two conditions will only run if they're less than the length. So we're going to add another conditional, which is if left is less than the length, if right is less than the length. And if the largest has been changed and the largest is no longer the parent index, then we want to swap the parent with the largest. And we're going to use, so we're going to have a conditional here that says if largest is no longer equal to the parent index. Okay, and we're going to use ES6 to swap the two indexes of the array. So we want to switch the parent index to the largest node. So in ES6, you can do this thing, which is pretty cool. You can have, you can set two values inside of an array to their new values, indexes. So this is the equivalent of swapping it, like setting a temporary value and then swapping it like that. This is just less less complex and just easier to swap and remember. Okay. And so then we want to call heapify again to recurse on the largest node. That's good. And after all of this, then we want to return array. So now that our heapify is written, let's move on to the heap sort. Heap sort is going to take in an array as an argument, and the first thing we want heap sort to do is to build a max heap. So we're going to write build max heap, and we want to build the max heap from the bottom up. So in order to do that, we want the last parent node of the array. So let's first make a variable for the length of the array, and then let's use the length variable to calculate the last parent node. So the last parent node of the array is really just the middle, so the length of the array divided by 2 minus 1. And in case we have a length of an odd number, like say 7, then we want to do a math.for. So we're going to do math.for length by 2 minus 1. So for example, in the array like this, and 1, 2, 3, 4, 5, let's say 6. Let's make it a length of 6. The last parent node will actually be 2. So with a length of 6, we divide by 2, and we get 3, and then we minus 1 to get 2. Okay. Let's comment that out. So next, we want to make sure we have a variable for the last child node as well, and that one's pretty easy. That will just be length minus 1. Okay. So we're gonna start off and build max heap from the bottom up. And we're going to start with the last parent node and keep heapifying until, we're going to keep heapifying all of the parent nodes until we reach the topmost parent node. So that sounds like a while loop. So while the last parent node is greater than or equal to 0, in which case it will reach the top of the tree, or the heap. Heapify r the length, because it's the full length of the array starting off. And then we want to call it the last parent node. And then we want to subtract this parent node minus minus, because then now each time, if we were to use this example, it will go from the last parent node of 2, and then it will heapify the parent node of 1, and then it will go to the parent node of 0. Okay. Next, after we have our max heap, we want to do a bunch of things. We want to swap the largest item with the smallest, and then we want to take the largest item off, and so then afterwards we would call heapify on the unsorted part of the array. So let's write another while loop for that. While last child is greater than or equal to 0. Like I said before, we're going to use ES6 to do a swap. Put this down so you can see. So we're going to swap the top of the heap with the smallest. After we swap it, we're going to call heapify. And we're going to call heapify on the unsorted part of the array. So in this case, we're going to pass in the array, and we're going to pass in the last child. So the last child is actually the length minus 1. So the last index of the array is already considered sorted, which is really important because we just swapped it. And then we're going to want to pass in 0 for the parent index. All right, because we want to sort it from the parent index top down. And then we are going to this. So this way we are calling heapify on every child. So last but not least, we return the array. All right, that should work. Let me try to make it so that you can see the whole code here. Okay, now let's run it. All right, there you have it. We have our sorted heap sort.